So good morning, good afternoon, and good evening, guys, based on the time zones you all are coming from. So guys, before we start with the session, can you all please give me a quick confirmation if you all can see my screen and hear me loud and clear as well? Perfect. Thank you so much for the confirmation, everyone. So before we get started, let me quickly introduce myself to you first. So my name is Neeraj Keria, and I have been working in this IT industry for more than 12 years now. So the main agenda for today's session, we are going to discuss on the components of Azure machine learning, where we are going to, first of all, we are going to discuss what exactly machine learning is. Before we discuss on what exactly it is and how exactly it is deployed on top of Azure platform, then we are going to learn on the machine learning fundamentals. Then we are going to discuss on the components of Azure machine learning, how machine learning is offered as a solution in Microsoft's Azure platform. And then we are going to see a demo on Azure ML Studio as a part of our discussion step by step as we move further. So now let's get started. So if we talk about machine learning, now first of all, let's discuss on what exactly is machine learning. So if we talk about machine learning, then machine learning is basically making sure that we are able to train the system with enough amount of data so that it can start behaving accordingly. So just like when we train any kid, for example, when we train any kid on mathematics, for example, we are training them on what exactly is 2 plus 2, it is 4. What exactly is 7 plus 9, it is 16. What is 21 plus 11, it is 32. So now we are training the kid here on multiple additions, on single digit and double digits. And now if the kid goes through the exam, and now if the kid sees a paper, if the kid sees a question, okay, what is 101 plus 12? Then the kid can try solving that complex problem by using the training it has been given. And that exactly is the same scenario that we do for real world systems. For example, we are building an image recognition software. So we have to first of all train the entire systems with hundreds and thousands of images and then designing the entire algorithm and making sure that the system is now able to distinguish other objects from the one that we are trying to locate by using the ML module. That exactly is what we try to do by using machine learning components here. So this is what exactly we mean by the machine learning concepts. Now, if we talk about multiple components of machine learning, then we have three types of learning offered by ML, or we can say machine learning module. First of all, we have supervised learning. So supervised learning is basically like a labeled. Now here in supervised learning, we use labeled data sets. Let's say we have labeled this creature as duck and we have labeled it as not duck. And now we are going to use this model for prediction modeling. Now by using this entire label data, now we are giving the system this particular individual. So based on the prediction model that we have created using these labeled data set, now using this prediction model, now the system can identify that this particular creature is not a duck. Why? Because we have labeled it as a part of being a duck or not. And this is what we do as a part of supervised learning. It means we have a complete control and we use labeled data set in order to make sure we are giving proper information to the system so that it can behave accordingly. Then we have unsupervised learning. So when we talk about unsupervised learning, we simply mean here we have multiple creatures which are not labeled. Like we have Donald Duck, we have Mickey Mouse, and then we have Bunny. So we have multiple multiple creatures which are not labeled. So when we are handling unlabeled data set and then using the unsupervised learning, then we can allow the system to segregate based on the features here. So there is no label that this is a duck and this is not a duck. But based on its learning here, we are segregating them based on the features that this one, and these three creatures, they have characteristics as of a duck, whereas these two creatures are not having any characteristics of a duck. So this is what we do by using unlabeled data in unsupervised learning. And then one more we have is reinforcement learning, when we are training the system to behave accordingly. For example, a simple use case is Now, when we are taking in feedbacks, for every action, for example, like we have self-driven cars. So the car runs into a wall, then we are going to give a negative feedback to the car for that particular action, so that the car can know the car took a wrong turn or there was something wrong. Then that's why the car crashed into the wall. So that's why we are using the feedback mechanism to continuously improvise the performance of the cars as well. And that's why if you talk about the entire learning methods here, we have supervised, where we use regression and classification modeling. Whereas if you talk about unsupervised learning, then we have the multiple clustering and association algorithms that we use in these two different learning types. All right. So basically, when we talk about regression algorithms, then regression algorithms basically attempts to discover and quantify relationships between different variables. And that's why by establishing a relationship between a dependent variable and one or more independent variables, regression analysis can enable the value of a dependent variable to be predicted given a set of inputs with a quantifiable accuracy. That's what we can achieve by using the regression algorithms. Whereas classification is the main goal of using a classification algorithm is to identify the class to which an observation belongs. It is based mostly on the training data consisting of observations which have already been assigned to a category as a part of classification algorithm here. Clustering is more of a like when we are seeking to pile a bunch of objects in a way that objects in the same group, which is referred as a cluster, are more similar to each other than those in the other groups as well. That exactly is what we do by using cluster. When we are going to identify a group of objects, then we can use the clustering algorithm for that as a part of our discussion one by one. All right. So that exactly is what we have as these different ML, as in machine learning algorithms used in ML here, component for both supervised and unsupervised learning. So if we talk about the entire setup here, then first of all, we have raw data. And then that raw data is, first of all, we need to pre-process any set of data that we want to work on, because pre-processing is really an integral component before we can start before we can start working on any of the components. Because before we can work on the component, we have to make sure we are able to remove all the anomalies, all the outliers, all the garbage values can be removed from the components of dataset. So basically here we are going to work on removing any garbage values that we may have as a part of data pre-processing here. And then we have to work on prepared data set, and when data is prepared, then we plug the data into the algorithm so that we can use that algorithm to work on the data. So that whatever logic we have defined, that logic can be applied to the entire data set that we have created by using the ML modules. And then here we create multiple candidate models. Then we deploy the entire model here to the entire infrastructure one by one by using the entire ML models here. Now, if we talk about the entire Azure component in machine learning, then Azure is just one of the provider for machine learning. There are multiple providers available, and that exactly is what Azure is. And Azure is basically used for making sure the entire model gets deployed on cloud, where we have to worry less about the entire infrastructure deployment one by one. That exactly is what we have as a part of the entire data modeling here. All right, so before we discuss on how to deploy this ML solution on cloud platform on Azure, first of all, let's have an understanding of why exactly we need to have a cloud platform. Now we can use if we go back almost a decade, then at that point of time, if we had a requirement of deploying any solution, then we had to purchase a complete stack of servers. We have to take care of the entire setup for drivers, configuration, its maintenance, auto scaling. Everything had to be done at our own end, right? Now we already have someone else who has done the entire infrastructure setup, and now that particular vendor is giving us the access to use their infrastructure to deploy any kind of data or application that we are looking to deploy, so that we do have to only pay for using the infrastructure, and the entire maintenance, setting up, maintenance, running, scaling up, these all things are being managed by the vendors itself. as a solution offering as a part of cloud computing. And that's why we have multiple players in the market. Like we have GCP, we have AWS having the biggest market share of around 39%, then followed by Microsoft Azure having a market share of 19%, and then followed by GCP having a market share of somewhere around between 9 to 11%. And then we have multiple other vendors as well who are the leader in the market one by one. And Azure is what is the second biggest cloud computing platform, where we have more than 100 plus, where we have more than 100 services offered by Azure, ranging from different categories, ranging on computation. We have services for computation, for storage, networking, migration, networking, different components, different services are offered by Azure as an offering. Again, Azure has having a good support for SLAs. It has some good advantages in terms of the service of the computation services as well, and that's why it is generally catching up on the market as compared to AWS platforms. So when we talk about the cloud computing platform like Azure, then Azure has multiple features, like it offers on-demand provisioning. That means here we can start and stop the resources exactly when we require. Let's say we require 10 additional servers in next 5 minutes, then we can easily deploy them without having any kind of constraints. We want to have the servers in launch and stop exactly on a timely basis, then we can do that. So whenever we want to add more number of servers or resources, we can do that easily, being a part of cloud computing platform. Then scalability in minutes. That means if we are looking to scale up and down the resources based on the amount of traffic we are getting, then we can do that easily by using the cloud computing platforms like we have Azure. And here we have to pay only for what we consume. That means, let's say if we are using 50 servers and that too for just 10 hours, then we can scrap those servers after 10 hours as well. We can easily do that. And we have the control of abstract resources. That means here we have to focus only on our requirements, not on the hardware specification. Whereas here we can utilize the entire skill set, knowledge, and resources of the experts because of the enterprise level SLAs and a dedicated support team that is assigned to us. And here everything is measurable. That means here we can measure each and every metric for the resources, including the billing that we are getting for the services that we're going to use on top of Azure platform. And Azure is having multiple services clubbed together. We have data centers, databases, we have database servers, computation services, AR, VR, IoT, blockchain, data migration. There are multiple services offered by Azure that we can use to get started. And once we start our discussion on Azure, there are multiple services that we are going to discuss step by step. In computation, we have the virtual servers. We have serverless computing platform also being offered. For migration, if we are looking to migrate our data from on-premise to cloud or from cloud to on-premise, we have solution for that. If we are looking to make sure that the entire security of the application is maintained, then we have services for that. If we're looking to maintain the entire storage activities, then we have services for that. Now, if you're looking to deploy any database services, then we have services for deployment of multiple databases, and that too on different engines. Like we have MySQL support for MySQL, Postgre, MariaDB. We have support from Oracle database engine as well. Then we have for messaging, we have different services for both messaging between different applications and messaging in terms of email service, and for notification of service as well. Then for networking, we have support where we can create our own networking components. As in our own virtually isolated network, we can go ahead and create by using the Azure services. And then for management, we have service through which we can create a complete controlled access for multiple users. We can define what kind of access they are going to have and till what extent we have to give them the access and how we have to revoke the access as well whenever we need to. So these all components are and they can be defined as a part of Azure platform. And we have a component for Azure now. Azure also offers something as ML Studio, or we can say machine learning service. So basically, if you talk about Azure Machine Learning, then it is a cloud-based service that provides a streamlined experience for data scientists at all the given levels. And this is especially important because of the fact that a lot of new engineers are trying to enter the space, and it can be particularly daunting to perform these tasks without an intuitive user interface. And the main advantages of Azure Machine Learning is it is fully managed. That means there are no softwares to install, no hardwares to manage, and once portal is used, again, we can use a single portal to view and update everything. It is well integrated. That means it has a simple drag and drop and connect interface for data science, where there is no need for any programming basics required. And it offers best in class algorithms. So it has a built-in collection of best of breed of algorithms, and it has support for R and popular CRAN packages. And we can deploy in minutes. That means we can operationalize models with a single click, and we can monetize it in machine learning marketplaces. We can easily do that. And basically, when we talk about the machine learning here, then ML is accompanied by ML Studio. So before we move on, let me showcase you how exactly it looks like in the portal. So for getting the access to Azure, we can enter a link called portal.azure.com. So if we have the account, we can sign up using account, or if we don't have the account, then we can use this link here, azure.microsoft.com, where we can sign up for a free account that is going to be valid for complete 1 month. So basically, when we sign up on AWS, we get 200 free credit that is given to our account that we can exhaust in 30 days. And after that, we get 12 months of popular free services. So there are some free services, just like we have AWS free tier. So there are some selective free tier services in terms of computation offered by Azure that we can use. And there are more than 25 always free services that we can use as a part of our free tier account on Azure. And once we have the account created, then we can log into a console. So this is what the console looks like for Azure platform. So if you want to get started here, we can use, now this is the entire homepage for Azure. And if you want to get started, we can click on create resource, and here we can see the entire list of all the available resources in Azure platform. We can simply use this to get started. So here we can see, here we have the resources for analytics, for blockchain, computation, containers, databases, developer tools, DevOps, identity, integration, Internet of Things, IT and management tools, media, migration, reality, monitoring and diagnostics, and networking services offered by AWS. Now, for looking for any specific service, we can use a search bar. For example, if you're looking for any services for machine learning, again, here we can see the list of all the available services under the category for machine learning that we type in. And if you want to get started by using the ML Studio, then we can define the ML Studio component, and then we can open it up as well. So here in the search bar, we can search for Machine Learning Studio available by Azure itself. Now, if you want to get started on defining the entire workspace, now before we can start by using the Studio, we have to create a machine learning workspace first. So now, when we talk about the ML Studio component, when we talk about ML Studio, then we have an entire service offered by Azure by the name of ML Studio, as in Machine Learning Studio. So basically, Azure ML is a cloud-based service that provides a streamlined experience for all data scientists at all the levels that we discussed. And it is accompanied by the ML Studio, which is basically essentially a browser-based tool that gave us, or we can say give any data scientist an easy way to drag and drop interface for the purpose of building these models. And most of the heavily used algorithms and libraries come out of the box for the users. And it also boasts built-in support for R and Python, letting the veteran data scientists change and customize the model and its architecture as per the requirement. So for example, if we have to get started, we can click on create on the machine learning workspace. So we have to first of all use the machine learning workspace itself, and then we can choose a resource group for which resource group we want to create. Resource groups are same like tags like we have discussed, like we may be aware for any other platform. If there are 10 different resources that we are deploying for a single application, then we can see the list of all the resources deployed for that app using the resource group. That means we can deploy all the resources for a given application in a given resource group. All right. And here we can define the workspace name. Let's say we want to call this workspace as Edureka itself. We can define the name as Edureka. We can define which region, because just like every other service, we have to choose a region in which we want to deploy the studio. Let's say we want to deploy this in East Asia, and then we can choose the edition. We can keep it to basic. Here we can choose, here we can review each and every parameters here. And once we are done, once it has been reviewed, then we can click on create. So basically deployment of services, they take almost 5 minutes in order for this entire workspace to be deployed. So as you can see, it says deployment is underway. So generally it is going to take almost 5 minutes. It may happen within a minute itself, or it may take up to 5 minutes in order for this entire services to be deployed. For example, here we can see the list of all the components that has been scheduled for deployment. So let's wait for a minute. So as you can see, now it has been deployed. Only one component is still being deployed here. So once it is deployed, we will be able to work on the studio. So basically, most of the heavily used algorithm and libraries, they come out of the box for the users. And it also boasts built-in support for R and Python, and where we can use it for getting started. So basically, the machine learning studio makes sure that the entire machine learning is fairly straightforward by providing a drag and drop way in which we can build the entire workflow, even if we don't have a comfort level with the coding. And with ML Studio and a greater number of modules it offers for modeling the workflow, we can make advanced models without writing any single line of code. So as you can see, this entire deployment is done. Now here we can create a machine learning directory here. So here we can go ahead and create one, just a moment. So currently this is the entire resource that we have currently deployed. And then if you want to get started, we can see here we have tried the new machine learning studio available. So if you want to get started, we can click on launch now, and then we are going to get into ML Studio dashboard where we can use the entire web interface. So basically ML Studio offers a complete graphical interface where we don't require to do any kind of coding, and the entire platform, that's why it is low code platform, which is based on ways to access capabilities such as ML. And here we can choose the drop down list, and in this case it is simply based on the drag and drop tool available. So here we can choose the default directory, we can choose a subscription method, we can choose a workspace that we have created just now, and here we can click on get started. So this is the entire dashboard for Studio that we have created. And now if we want to start working on the notebooks, on dataset, experiments, defining pipelines, modeling, defining the endpoints, then we can declare all of these components one by one, and then we can get started. So let's say we give this name as financial data that we are going to use, and then we are going to upload a sample location file. And here we can choose the dataset type. Here it is going to be a tabular, or it is going to be a complete file dataset. Here we can choose a file, and then we can define the location of the file. Here we can simply create a new data store. Here we can browse the entire file, and then we can click on next, and here we can click on create. So this is going to create a simple financial data set that we are going to use. And if you want to see the entire report, it means the entire metadata here, we can see the entire data set available that we are going to use for our financial machine learning models. So here we can create multiple data sets that we want, and then we can go ahead and create multiple experiments as well. So again, if you want to create an experiment of our own, we can click on create experiments, where we can start from scratch, or we can start creating where we can start using any of the sample experiments that we want to explore. For example, in sample experiments, we can explore multiple samples available for Python and both for R as well. For example, now here, if we go ahead and explore samples, then here we can use the sample sets for Python. Here we have for reinforcement learning, how we can work with data, how we have the entire training data set available. So let me share another sample with you all. And if you all wish to download this entire sample workbook file, the sample data set that we have downloaded, I'll be sharing the link with you all towards the end, so you can use it as a reference. And before we can start working on deployment of the entire data set here, we have to make sure we define the entire computation and data source requirement beforehand. So basically, when we are trying to build any models, either for experiments or we are adding any data set, we have to also define the entire computations. That means how many nodes we want, how much of resources we want, that we have to define. So here we can click on computation node here. Here we can define create. And then we can define the virtual machine type, whether we are going to use CPU or we can use GPU as well. So we can define the entire virtual machine type. We can keep it to CPU or GPU. If we have more resource intensive requirement, then we can use the GPU as well. Then we can choose any given size. Depending upon the requirement. For example, if we are choosing CPU, then we can choose from a wide range of collection from the given instance type, that where we can define the number of cores, the RAM, the disk available for different use cases. Now currently we have defined one particular region, and before we can use the reserve instances, we have to define the quota in our account. Then only we can get started. So here we can choose any of the instance type that we want to get started with. Suppose if you want to use standard, if we want to enable the SSH access, we can enable it. But then we have to define a key, because if we're using any SSH client, we also have to define the key as well. So here we can see the entire list of all the available GPUs for the given region. For example, if we want to see the pricing for West US2, and here we can see the entire capacity, the GPU, the pay as you go model here. That means how much we have to pay on a RD basis. And if we are going for the reserve instances, that means paying upfront, then how much of money we have to going to pay upfront, and how much of savings we'll be having for the particular GPU. All right, guys, so thank you so much for joining, and have a great day ahead. Take care. Bye-bye.